What is linear regression? How is it used? Also, what are some of its limitations? If you're like me, these questions would have never crossed your mind until taking a statistics class. Linear probabilistic modeling, or linear regression, or sum of squared residuals, or method of least squares. Yes, it has a plethora of names, but it all boils down to a method of using a combination of one dependent variable and one or more independent variables to develop a nice scalar model that will allow us to predict the outcome of the dependent variable at any point and use this to minimize or regress error, like comparing metal hardness to the time and temperature it is treated at, or we can quantify if a relationship between parameters even exists, like comparing the density of metal to how long it's been sitting in a warehouse. That sounds like a lot of variables, but you just need to bring it down to the ones you want to focus on. I'm going to do a fairly simple example based on something an engineer may need to brief management on: the predicted cost versus the actual cost to machine a part. Now, have you ever wondered why it's called the sum of least squares? Well, your question has been answered. Literally that simple. We take the residuals or errors and square them. Remember, we square them to exaggerate the larger errors, and sum them all up, which gives us our sum of squared errors, or SSE. Next, we use these formulas to make a scalar equation, which is then used to make a new regression line. As you can see, the squares and values are much smaller than our first graph. What does this mean? It means our predicted cost based on the number of hours projected to machine a part is off by a factor of 0.8261x plus $187.43, where x is the number of hours it takes to finish the part. If we can combine that with an engineer's knowledge of the complexity on machining a part and the limitations of the equipment, then we can steadily work that prediction down to a goal of zero variability. Now, what are some of the limitations of this technique? There's one major limitation in that if you don't put bounds on your independent variable, you can end up with a linear regression that has upper and lower bounds of negative and positive infinity. In some cases, if we end up with a negative intercept, a part that only takes 10 minutes would end up with a negative cost. I don't know about you, but telling my boss that we need to pay somebody for work we did on their part probably won't go over very well. Like I said, this is a fairly basic example. Some others include, but aren't limited to, glove chemical permeation time versus breakthrough time, transmission power versus signal strength, or we can use it to predict project costs, which allow for better allocation of funding in an engineering company. There are many ways to use this technique, and I hope this video has helped you gain an understanding of the possibilities. Take care, and happy regressing.